Have you ever wondered why you can be utterly exhausted at 3 in the afternoon, yet uncontrollably wired at midnight? Well, let's dive into this explainer and fundamentally shift our mental model. You see, most of us have been taught to view sleep and metabolism through this lens of sheer willpower and generic health rules. But today, we're going to bypass all that. We're going to look at the exact cellular mechanisms running your body. We are going to explore how sleep, stress, digestion, and cognitive resilience are not isolated functions. Actually, they're synchronized outputs of a highly sensitive, deeply interconnected biological network. Think about it. If you're struggling with midday crashes, brain fog, or stubborn weight gain, it's very likely that the evolutionary hardware inside your brain is completely misaligned with the software of your daily life. So, rather than just giving you a list of generic sleep hygiene tips that you've probably heard 1,000 times, we need to ask a much deeper, more mechanistic question. Is your endogenous timekeeping system actively struggling against your modern environment?
To understand exactly why this happens, we have to start deep inside the brain. Right in the anterior hypothalamus sits a highly specialized cluster of exactly 20,000 neurons. Just 20,000. Out of the 86 billion neurons in your entire brain, this tiny microscopic cluster dictates almost every rhythmic biological process in your entire body.
This cluster is the suprachiasmatic nucleus, or SCN. It's your master biological clock, sitting perfectly positioned right above your optic nerves. But here is the fascinating mystery. Buried deep in the absolute dark vault of your skull, how does this tiny cluster of neurons actually know what time it is outside? How does it sync your internal biology to the physical rotation of the Earth? The secret lies in a dedicated neurological highway. Environmental light actually bypasses your normal vision and hits specialized melanopsin-expressing cells right in your retina. This triggers a signal that travels directly down the retina-hypothalamic tract, plunging into the core of the SCN, where it sparks a precise chemical cascade involving gastrin-releasing peptide. That specific spark, that neurological wiring, is how your brain literally winds its internal watch.
Section 1. Sleep pressure versus circadian drive.
Okay, think of these as two opposing forces locked in a daily tug-of-war. Process S is your homeostatic sleep drive. Every conscious second, your neurons are burning energy, leaving behind a metabolic ash called adenosine. As this adenosine accumulates, it creates immense sleep pressure. Process C, however, is the circadian alertness signal driven by your SCN. And process C is actively fighting that adenosine pressure with a powerful alerting signal to keep you awake and functional during the day. This constant interplay isn't just about feeling sleepy, you know. It's an invisible symphony. The SCN sends signals cascading down your autonomic nervous system to spike your cortisol to wake you up, drop your core temperature to initiate sleep, and release melatonin from your pineal gland. It happens every single day, precisely on schedule. And this exact mechanism explains a phenomenon we've all experienced, the evening second wind. Have you ever wondered why, after feeling completely exhausted at 3 p.m., you suddenly feel wide awake at 8 p.m.? Well, it's because your SCN is compensating for a full day's worth of accumulated adenosine by firing its absolute maximum alertness signal in the late afternoon and early evening. It's pushing back against that sleep pressure as hard as it possibly can, right before process C finally drops off at night, allowing the adenosine to take over and pull you down into deep sleep. Section 2, Peripheral Clocks and Metabolic Health. To grasp the true systemic nature of human biology, we have to zoom out and realize you have peripheral circadian oscillators, basically secondary biological clocks, in almost every organ in your body. Your liver, your pancreas, your gastrointestinal tract, they all have local clocks. But here is the profound twist. Unlike the master clock in your brain that's listening for light, these peripheral clocks in your gut are entirely deaf to the sun. They are entrained almost exclusively by the timing of your very first bite of food. Which brings us to a major clinical distinction. Intermittent fasting is widely known as a behavioral tool to restrict your daily eating window, mostly to reduce overall caloric intake. Chrononutrition, however, is fundamentally different. It aligns your food intake specifically with the functional, biological windows of these peripheral clocks. The goal isn't just cutting calories, it's preventing chronodisruption, the metabolic chaos, weight gain, and systemic inflammation that ensue when you force your liver and pancreas to work a night shift. Here is where the biology becomes truly unforgiving. If you eat a meal late at night, the melatonin that's currently flowing from your pineal gland to prepare you for sleep actively binds to receptors on your pancreas and literally shuts down the secretion of insulin. So you aren't just eating late, you are actively eating against your own endocrinology, guaranteeing a massive, prolonged, and highly damaging spike in your blood sugar.
Section 3. The phase response curve and biological levers.
Knowing how intensely sensitive this interconnected system is, how do we actively manage it? Well, we use the phased response curve, or PRC. You can think of this curve as the hidden operating manual for your brain's clock. It is a highly precise mathematical map showing exactly how different external stimuli will advance or delay your biological rhythm, depending entirely on the exact hour they are applied. There are 3 primary levers, or Zeitgebers, which means time givers, that we can pull. Light is the sledgehammer, capable of shifting your central pacemaker by up to 3 full hours. Exogenous melatonin acts as a chemical override, bypassing the eye to directly target receptors in the SCN. And physical exercise uses systemic stress signals to align both the central clock and the peripheral clocks in your muscle tissues. Looking specifically at the light phase response curve, we see a fascinating vulnerability in human biology. Morning light acts as a powerful phase advance. It pulls your biological clock earlier. But evening light, it actively tricks your SCN into thinking the sun is still up. Evolution literally never prepared us for the blue light of a smartphone at 11 p.m., so that light forcefully delays your rhythm, pushing your sleep onset later and later into the night. Now, when it comes to melatonin supplements, the clinical data presents a massive contradiction to what you typically see in the pharmacy aisle. To actually shift the circadian clock, sleep physicians utilize a microscopic dose of just 0.5 milligrams. Those massive 5 or 10 milligram doses, they just flood the brain, causing trailing blood levels that spill over into the wrong physiological zone of the phase response curve. It completely confuses the SCN instead of cleanly shifting it. And the exercise phase response curve reveals another really crucial mechanism. We usually think of exercise simply as a way to tire ourselves out, right? But timing is absolutely everything here. A high-intensity run at 7 p.m. will actually induce a phase delay, actively keeping your biological clock awake and leaving you staring at the ceiling for hours. Conversely, an afternoon workout acts as an incredible tool to naturally advance your sleep phase.
Section 4. Clinical protocols for circadian resetting.
Let's look at severe night owls, clinically known as having delayed sleep-wake phase disorder. We don't just prescribe a sleeping pill. That's a Band-Aid. Instead, we induce a coordinated phase advance. This involves blasting the retina with 10,000 lux of white light immediately upon waking, scheduling morning exercise, and administering that tiny 0.5 milligram dose of melatonin timed exactly 5 hours before the target bedtime. Conversely, if you involuntarily wake up at 3 a.m. every day, we must induce a phase delay. This requires wearing literal light-blocking goggles in the morning to hide the sun from your SCN and prescribing high-intensity light exposure in the early evening. That evening light actively suppresses premature melatonin release and delays your biological night. And you can use these exact same biological levers for acute environmental disruptions, like jet lag or the metabolic chaos of night shift work. If you're flying east, you aggressively seek morning light to advance the clock. If you're a night shift worker, you utilize bright light during the overnight shift, and then wear deeply tinted glasses on the commute home to effectively blindfold your SCN from the morning sun. The overarching lesson here is profound. You cannot hack your sleep if your liver is awake digesting a late-night meal, and you cannot fix your fatigue if your brain is receiving bright screen light at 11 p.m. They are not isolated behaviors. They are one unified biological network. Because once you understand the exact cellular mechanisms running your master clock, you realize that optimizing your resilience, your metabolism, and your cognitive clarity isn't about brute forcing your way through the day with caffeine. It is about understanding the magnificent evolutionary machinery you inhabit and aligning your behavior with the rhythms etched deep into your brain. So now that you know exactly where the biological levers are, how are you going to set your clock?